Good morning everybody and welcome to EduSet Society. Myself Amandeep Kaur from GPCG Patiala and lecturer in information technology. Today I am here to discuss a topic of relational database management system with all of you, and it is relational model. The contents that we will be studying in today's lecture will be relational model. What is relational model and what do you mean by a relation, attribute, degree of a relation, cardinality, domain, tuple and relational schemas. All these terms are basic terms related to relational database management system. In order to understand better the relational model, you need to be aware from all of these terms, and after that we will be studying the properties of relations and relational constraints and relational integrity. Before going into any kind of details of the relational model, I would like you to introduce with the data models. What are the data models and why do we need them? First of all, what is a data model? A data model basically is a method of representation of facts and data which is stored in the database, and we need to define some sort of constraints on the data which is to be stored in the database. The constraints are basically the rules and regulations which are to be followed by the data which will be stored in the database. There are various models in relational database management system which are available for the users in order to choose a representation to store the data in the database, and these are hierarchical model, network model, relational model, object oriented model and physical data models. But today we will be studying relational model. Basically the relational model is a method of representation of facts in a tabular method, in a tabular way. A relational database consists of a collection of tables which combines rows and tables, each of which is assigned a unique name, which means a relational model simply represents the database as a collection of relations. Here one thing is noticeable, that is, in a relational database, whenever you are talking about a relational database, the data will be stored in the form of tables, each containing rows and columns. In a table, the rows will represent the tuple or records, and the column will be representing the attributes or the data items which will be representing the database. Each relation resembles a table of values. Each and every table which is in the relational database, it will be resembling a table which contains various values stored by the user. Each row in the table will be representing a collection of related data values. For example, if you are storing information about a student, then each row in that table or a relation will be representing the information regarding a student. For example, the name of the student, class, address, phone number, etc. So basically the relational model is a collection of tables of rows and columns. Now we will be studying in detail the basic terms which are associated with a relational model. In order to understand the relational model in a better way, you need to be aware of all of these terms. First of all, first term is relation. A relation is a table with columns and rows. In relational model, you won't call a table simply a table, you will be calling it a relation. It contains rows and columns. The columns will represent the attributes and rows will represent the tuples or records. Second term is attribute. Attribute is the named column of a relation. For example, if you are storing information about a company, the employees of a company, the employee ID, employee name, employee salary, employee address, all these will be attributes of that particular relation. Degree, next term is degree. The total number of columns or attribute present in a relation are considered to be degree of that relation. Simply the number of column present in a particular table or relation will be considered the degree of that relation. For example, if we are having 4 columns, we are having 4 attributes in a particular relation, then its degree will be equal to 4. If you are having 6 columns or 6 attributes of a relation, the degree will be equal to 6. Next term is tuple. Tuple can be a row in a table is known as a tuple. Whenever you fill values about any entity or about any subject in a particular table, the complete row in a table is known as a tuple. It can be called as a record, as it can be called as a simply row. Cardinality, next term is cardinality. The total number of rows present in a relation is considered to be the cardinality of that particular relation. Now one thing is noticeable, that total number of columns or attributes of a relation are known to be degree of that particular relation, but the total number of rows present in a relation is considered to be the cardinality of that relation. So we don't have to confuse these two terms, because they are two different terms in relational database management system. So cardinality is total number of rows or records present in a relation. Next term is domain. A domain in relational data model is the set of allowable values that can be assigned for one or more attributes. Now it is noticeable, what is domain basically? Domain is, for example, if you are talking about how much age can be entered in a particular column. If we are having a age column in our relation, and we need to define the value which can be stored in that particular column. Now if we have if someone is entering 150 age and it is illogical, so the relational database management system defines a set of allowable values which can be assigned, which can be entered in a particular attribute or one or more attributes at a time. This is known as domain, set of allowable values simply. Next term is relational schema. In general, a relational schema consists of a list of attributes and their corresponding domains. Schema is basically the overall design of the database, and by the term relational schema we mean a relational schema will be consisting of a list of attributes and their corresponding domains. Number of attributes, there will be attributes of a particular relation and their corresponding domains. Domains means allowable values which are assigned to those particular attributes. So these are basic terms which are associated with relational data model. Now we are aware of all these terms. Now we can move on to next slide. Next term is components of a relation. Components are basically two things which from which a relation can be made up. A relation in a relational database management system has two components, namely extension and intention. Now we will discuss these two terms in detail. First of all, what is extension? Extension is the set of tuples appearing in that particular relation at any given instant or any given instant of time. Extension is basically the number of tuples which are present in a relation at any given instant of time. It is noticeable that extension of a relation varies with time. For example, if we talk about if we have just created a relation right now, and it will be containing no rows or no data at all, but along with time, whenever the user will enter the database, the extension of the database will also change along with the time. As soon as you will change the rows or rows which are present in a table, the extension of the table will be affected along with that. But intention of a relation is independent of time, as the extension of a table was dependent upon time. Whenever the user will change the relation, the rows of a relation, the extension of the relation will also change, but the intention is independent of the time because it is the permanent part of the relation. Intention of a relation is combination of two things basically, a naming structure and a set of integrity rules. As the name implies, the naming structure will be including relation name and the names of attributes. It will be specifying what kind of name you are giving to your relation and what are the names of the attribute which are present in that particular relation. And the other thing, a set of integrity rules, it will specify the certain rules and regulation which are to be applied on the data which will be stored in your database. The integrity constraints can be further subdivided into various constraints which are key constraints, referential constraints and other constraints. Like key constraints are the constraints that are implied by existence of the candidate keys. If you are having candidate keys in your table, then only you will be using the key constraints. But if you are not having candidate keys, then this constraints cannot be applied on the table. Candidate keys are basically simply it specifies that if your table is not having a primary key, you cannot use the key constraint on your table. So these are the components of a relation: a naming structure and set of integrity rules. Next term is relational schema. As I told you earlier, schema is the overall design of the database. It is defined by a named relation by a set of attributes and domain name pairs. In relational schema, we can include the various attributes of a table and their corresponding values. For example, let A1, A2, A3 up to AN be the attributes with domain. We are, for example, we are having number of attributes from A1 to AN, and consider D1, D2, D3 up to DN. These are the set of domains which are assigned to those particular attributes. Then the set A1 belongs to D1, A2 belongs to D2 and A3 belongs to D3. It will be known as a relational schema. Simply, the attributes of a relation and their corresponding values which are assigned to those attributes is known as a relational schema. This is the diagram of the relational schema. We are having a table employee and we are having various attributes in that particular relation. E-code stands for employee code, name, gender, address, salary and phone number. Then there are two other tables, department and project. Department having two attributes, T number and D name. Project having four attributes, P name, P code, P location and E code. This is the schema diagram for a company's various relational schemas with primary keys underlined. The attributes which are underlined, these are known as the primary keys. These will be having the unique values. A relation R defined by a relation schema S is a set of mappings from attribute names to their corresponding domains. Relational database schema, next term is, it is a set of relational schemas each with a distinct name. A single table will be called a relation, and when you will be having a number of relations in a particular database, then all of them will be considered as various relational database schemas, because they will be having all distinct names and all will be having the different kind of attributes. This is the overall database state. As I told you earlier, this is the particular diagram of that particular relation. We are having the degree, number of attributes present in a relation are known as a degree, and the number of rows in a table are known as integrity, cardinality of a relation. Various attributes of the table are e-code, name, gender, address and salary. This is a particular representation how you can store data in a relational database management system. It is stored in the form of tables and you will have to specify the primary keys. Each table will be having a primary key. Next topic is properties of a relation. Whenever you are defining a relation in the relational database management system, you need to take care of certain things before its design. These things are general properties of a relation, which are considered to be the important things whenever we are designing a database. The relation name has a name that is distinct from all other relation names in the relational schema. Whenever you are designing a relation or a table, a new table in your database, you need to take care that it should have a different name from all other relation names, so that the values which are to be stored in that particular relation should not conflict with any other table. Next is, each cell of the relation contains exactly one atomic or single value. From here, atomic value, we specify that the value should not be divisible in some other parts. So each cell of the relation, that is each column of the table, should contain at most only one value. Next property is, each attribute has a distinct name. You will be having number of attributes in your table, but you cannot give a same name to more than one attribute. For example, you can have name column only once in your table and you cannot write it twice. So it will be the violation of constraints. Next is the values for an attribute are all from the same domain. Next property is each tuple is distinct, there are no duplicate values or tuples. This thing specifies that because we have designed the relational database management system in order to eliminate the duplicate values which could be stored in the manual paperwork. So in order to maintain the distinctity of all the values, we need to take care that each tuple, each row in your database is distinct. That means it will not be holding duplicate values. Next is the order of attributes has no significance. You can write the attributes in any kind of order and it doesn't have any kind of significance. It cannot affect your database at all. Next is the order of tuples has no significance. The way you have stored your rows or records in your table, it also doesn't have any kind of significance. So these are some general properties of a relation that it should possess. Next thing is relational constraints. First of all, what are constraints? Constraints are certain rules and regulations which are applied on the data which is stored in your database or which is to be stored in your database. In case your data does not comply with all these constraints, it is violating any kind of constraints, that it cannot be allowed to enter in your database. So let's start with this topic. In any complete DBMS, that is database management system, we find difficulties to prevent incorrect data from being stored in the database and to prevent the reading of data that should not be disclosed to the person reading. So in any kind of database management system, we don't want to enter the incorrect data in your database, and along with it you would like to keep the privacy of your data, so that the person who is not authorized to read your data should not read your data. Generally, there are two sources of incorrect data. One is accidental data, such as you can mistype the errors, and second is malicious use of database. These are the intruders which can hack your database and they can thus misuse the database. So we can divide this problem of protection of the database in two types basically. One is integrity preservation and the second is security of your database. Integrity preservation concerns the non-malicious errors and their prevention. These will be the mistyping, or you can take the spelling mistakes done in your database. And the second thing is security of your database. Security is basically concerned with restricting certain users so that they are allowed to access and or modify only a subset of your database. It might appear that any attempt on the part of user to access a restricted portion would be malicious. So integrity preservation will be taking care of the mistyping errors which are done by the user, and the security aspect will be concerned with the restriction of certain users. There must be some kind of data which should not be disclosed to everybody. So the user can provide certain kind of restrictions by which the user will be allowed to modify or read the data, which is the subset of the actual database, which is not actually database. And any kind of attempt, if a user attempts to access that particular restriction portion, the database can prompt the user not to access that database. To handle such conditions like protection of your database, DBMS has provided number of constraints to preserve integrity and security. These constraints are namely domain constraints, entity integrity, referential integrity, assertions and triggers. By including all these constraints in your database, by applying these constraints on your database, the user can protect the database against integrity and security. First of all, what are domain constraints? as I told you earlier, domain is basically a set of allowable values which are assigned to one or more attributes. Domain integrity ensures that only a valid range of values is allowed to be stored in a column. No invalid value can be entered in a column. For example, if age is stored to be 200 years, which is an invalid value, so these kind of things cannot be entered in your database. Domain constraints are more elementary form of integrity constraint. Domain is possible set of values that must be associated with every attribute. Declaring an attribute to be a particular domain acts as a constraint on the values it can take. The domain constraints are tested easily by the system whenever a new data item is entered into the database. The data type associated with domain typically includes standard numeric data types of integers and real numbers, characters, fixed length and variable length strings are also available as date, time, etc. It can be enforced by restricting the type of data, range of values and format of data. For example, if a person enters integer values in the name column of a particular table, then this domain constraint will be violated by that particular user, and in some situation the DBMS will not accept such values for a particular domain or for a particular attribute. So this is the function of domain constraints. You can restrict the type of data and the range of values and the format of data which is to be entered in a particular attribute. By enforcing the domain constraint, you can enforce the accurate entry of your data. No incorrect data will be entered in your database. Next constraint is entity integrity. As the name implies, it refers to the uniqueness of your database. Entity integrity ensures that each row can be uniquely identified by an attribute which is known as a primary key. As I told you earlier when I was discussing the diagram with you, each of the tables should be having a primary key. Primary key is mandatory for all the tables in order to identify themselves uniquely in among other tables. Whenever a table does not possess primary key, it is difficult to identify that all the tuples which are present in that table uniquely. And along with it, we need to specify the primary key cannot be null. That means every time whenever you are entering values in your database, you need to enter the particular exact value in the primary key as well. You cannot leave this column blank and you cannot enter any other kind of value which is not supposed to enter in that column. A relation is identified by a set of tuples. By definition, all the elements of a set are distinct, which means all tuples in a relation must also be distinct. For example, no two students should be having two same roll numbers. So in the simply by having that definition, we can say all the tuples of the database should be having own primary keys and no two tuples will be having same primary keys. It describes that no two tuples can have the same combination of values for all their attributes, and in case it happens, it will be violating the consistency of your database and you will be having redundancy, that is duplicacy in your database. Next constraint is referential integrity. There are number of tables which do not possess any kind of primary keys. In that case, to identify themselves uniquely, these kind of tables have to refer to other tables which are having primary keys. And in that case, referential integrity ensures that all the values in the foreign key match with the values in the primary key. It specifies the foreign key column should be having the values which are matching to the values of primary key. It ensures that the data in the database remains uniformly consistent, accurate and usable even after that data in it has been changed. By enforcing the referential integrity on your database, you can ensure the consistency of your data. That means your data which is in your database is correct and it is accurate and it is usable even after the data which is stored in your database has been changed by a number of users. The referential integrity is specified between two relations. One will be having the primary key and the other will be having the foreign key. It ensures that a value that appears in one relation for a given set of attributes also appears for a certain set of attributes in another relation as well. This was the referential integrity constraint of the database. Next topic is assertions. Assertions is a predicate expressing a condition that a database always satisfies. Domain constraints and referential integrity constraints are special forms of assertions. These are used for testing the assertions and are applied to wide range of applications. Assertions are basically a kind of condition which is enforced on the database and the data which is to be stored in your database. The information which is satisfying that particular condition, only that will be allowed to enter in your database. Other than that, information will not be allowed to enter in your database. Further, we have an example to better understand the concept of assertions. For example, the sum of all the loan amount for each branch must be less than sum of all accounts of the branch, and the second condition is every loan has at least one customer who maintains an account with minimum balance of rupees 15,000. So these are two basic conditions which are applied on a bank. First of all, first condition is sum of loan amount should be less than accounts of the branch, and the other condition is whenever a person applies for a loan amount, his minimum balance of his account should be 15,000, less than 15,000. And the syntax of assertion is you will write create assertion and you will specify the assertion name, then check, then you will be writing the predicate. Predicate means the condition which is to be satisfied by the database. When an assertion is created, the system tests it for validity. Whenever you will create an assertion, the system will test it for its validity. Validity means is it right or not. If the assertion is valid, then any further modification to the database is allowed only if it does not cause that assertion to be violated. As I told you earlier, for example, if a person does not possess minimum balance 15,000, then he will not be allowed to apply for the loan amount, for any kind of loan amount. Same thing is written over here. If the assertion is valid, only then future modification to the database is allowed, and that too only in that case that the assertion is not to be violated. The assertion is maintained by the database system. Next constraint is triggers. Triggers basically is a statement that a system executes as a side effect of a modification to the database. These are the statements which are executed by the relational database management system whenever you are doing any kind of modification to your database. For example, if you are inserting data or you are updating the information or you are deleting any kind of information, every time you will do anything and the trigger will be executed as a side effect. A trigger can also be interpreted as a special kind of stored procedure that is executed whenever an action such as data modification takes place. It can also be taken as a stored procedure which is executed whenever any action on the database is performed by any user. A trigger is always defined on a table and is said to have fired whenever the data in the database is affected by any DML commands. Here it is noticeable that the trigger will be fired only when you are operating any kind of DML command on your database. DML stands for data manipulation language. It consists the commands which are meant to update the contents of the database, and these commands are insert, update and delete. Whenever you will use any of these commands on your database, a trigger will be always fired. DML statements like insert, update, delete, they cause execution of a trigger. You will insert any kind of information, you will update the information of your database, and you